Hi friends, welcome you all once again to our session, Geography. So in the last session we have dealt about the composition of the atmosphere and we have dealt with some important topics under the session. So this video is just a continuation of that module 2. So today we will be discussing about a small topic which is the insolation. Okay, this appears to be a small topic, but based on this topic there are many concepts that are going to be unlocked. Okay, so this is very important. So before I start, I thought I'll share some Facebook post what I saw today in the morning. The title of the Facebook post is like be like boxing. Okay, I hope you all know about the boxing game, somewhat the rules you know, I hope. Okay, so in boxing what happens is, boxing is the only game where if you fall down, if you are kicked by your opponent and if you fall down, you are not defeated. Okay, the referee will give some time. And in that time, if you are not getting back to the post, if you are not getting back, then you are being defeated. In the boxing term, you are knocked out. Okay. So when you are defeated and if you fell down, you are not defeated. But if you refuse to get back again, then you are defeated. So be like boxing. Okay. As an aspirant, we also fell down, like prelims result, mains result or interview, we'll fell down. But whether you get back or not, that's the question. Okay. So wait for the day when you see your name in the list. Okay, so wait for that day and be motivated. So that's the spirit, and that with that positive note, we'll start today our small topic of insolation. So what is the main source of energy for this atmosphere? We all know that is the sun. Okay, so sun is here, bright sun. So what is the temperature? Sun is so much hotter. Okay, so what is the temperature of the sun? It will be around 10,000 Fahrenheit. That much of heat it is producing, and you all know Earth is here. Okay, just an example. Just this diagram is an example. Okay, so what happens is the sun's rays are directly falling on the Earth. So this sun's rays travel about approximately 90 miles. Okay, 93 miles roughly. 93 miles the sun's rays are traveling and it is falling on the atmosphere, on the outer layer of the atmosphere. This process is known as insolation. Okay, it appears very simple, right? Insolation, sun is there, the rays are coming and falling on the atmosphere. This process is known as the insolation. So now we'll go a little more deep. What happens is, the radiation that is coming from the sun, okay, it is divided into two parts. One is the visible light, what we can see from the sun's rays. If you go to your upstairs and you can see the sun's rays, that is the visible part. The another one is the less visible, ultraviolet and the infrared radiations. Okay, what is this ultraviolet? What is infrared? I think I don't want to go much deeper into UV and IR rays because that is more related to your science and environment. So now we are dealing with geography. Okay, so visible and less visible. Okay, visible that you can see in your naked eyes, less visible UV and IR rays. IR rays are used in photography. There are some features. Please note down those features, UV rays and IR rays, that is important with regard to your science and tech concept. Okay, so that is about the difference. And now what happens is, there is two terms. One is the solar constant. Okay, what is the solar constant? In the Earth, if you take a unit area, okay, if you take a unit area and what that unit area is getting sunlight, okay, that unit area is receiving sunlight, that is known as solar constant. I'll read the perfect definition of solar constant. Solar constant is nothing but it is the rate per unit area at which the solar radiation is received at the outer limit of the atmosphere. Okay, same as insolation, but per unit area, that is a term known as a solar constant. There is another one term known as the albedo of the Earth. Okay, we all know sun's rays are coming from the sun and it is directly hitting on the Earth, and some are being absorbed and some are being radiated back. Okay, so that amount of energy which is being radiated back is known as the albedo of the Earth. Okay, so these two concepts are very clear. Solar constant nothing but the rate per unit area which the sun's rays are attracted or absorbed, that is known as solar constant, and the rate at which it is being reflected back, that what amount it is being reflected back, that is known as the albedo of the Earth. Okay, so sun is here, the hot bright sun is there and the rays are being coming from the sun and hitting on the outer layer of the atmosphere. So approximately some 35% of the sun's rays are directly reflected back. Okay, when it is reaching this outer layer of the atmosphere without being absorbed, these 35% are being reflected back. So this 35% is of no use to the Earth. Another 14%, These 14% are observed by the particles present in the atmosphere. What are the particles present in the atmosphere? That we have dealt in the previous video, composition of atmosphere. So those composition of atmosphere like CO2, the dust particles, the gases involved in the atmosphere, that will scatter. Okay, these 14% of the sun's rays are being observed and scattered by those particles present in the atmosphere. So out of that, out in this scattering, the blue color, okay, the blue color is present, prevalent in the atmosphere, and it is blue is one of the shorter wave. Since that's why this blue color is scattered the most, and you can see the sky as blue in color. This concept you could have studied in your elementary. Okay, so this 14% is being absorbed by the particles present in the atmosphere and are being scattered. So 35, 14. So remaining is the 51%. This 51% is only of use to the atmosphere, or this 15% only reaches the inner layer of the atmosphere. Okay, so that is the concept here. So how this 51% is being absorbed by the earth, that we will see. So we all know this 51% of the sun's rays are entering the atmosphere. Okay, so now I have a question for you. This is the land surface, and I have 3 points here: A, point B, and point C. This is the lower layer of the atmosphere. Okay, ground surface. So in which the 51% of the sun's rays are entering the atmosphere and are being reflected back. That is okay. But just answer my question. In these 3 points, in which point the temperature will be maximum? Either A or B or C. If you know the answer, just pause the video and just try it in the comment section. Okay. Which point the temperature will be maximum? The answer is A. Okay. Because you will think that this point C will be the maximum because sun's rays are coming from above, right? So here it will be maximum. That is our presumption, but that is not happening because of the concept known as the terrestrial radiation that I have dealt in the previous video, terrestrial radiation. So understand one thing very clearly. Sun's rays, when it is coming from the above, it is not heating. When the sun's rays, the incoming short waves which are coming from the sun's rays, while it is entering the atmosphere, it is not going to heat your layer of the atmosphere. Okay, it will come. This point C, it will not heat. This point B, it will not heat. It will come down, and here the reflection will happen. Okay, the part of that 51% will be absorbed by the land surface, and the remaining is being radiated back. Okay, so while it is coming and it is being radiated back, okay, so the heating starts from this area only. While it is being radiated, this area starts heating. Next B, next C. Okay, so the heating process is not like this. It is happening like this only, from A to B to C only. That's why you can see the maximum temperature at the point A and not at the point C. This concept is known as the terrestrial radiation with respect to this 51%. The 35% is of no use, and this 14% is being absorbed by the dust particles and other particles, other gases present in the atmosphere, and it is being scattered. Okay, because of that, blue sky is formed. That is a sub-concept of that. And this 51% terrestrial radiation. This is the concept. Now I will I will throw this concept, or I will extend this concept, and I will ask a brilliant question to you. This is the land surface, right? Now here I will draw a water surface. Let us take, this is continent and this is oceans. Okay, so this is land and this is ocean. So we all know this 51% of the rays are coming and are being radiated back. So now answer my question. Whether the land or the ocean, this continent or the ocean, which will get heated fast? Okay, which area will get heat fast and which area will radiate the heat absorbed very fastly? The quick heat process, where it will take place, in the land or at the ocean? If you know the answer, just write in the comment section. So the answer is your land surface. Okay, your land surface gets heated up more fastly and more quickly, and it radiates the heat more fastly than your ocean. Okay, so what is the reason for that? There are many reasons for that. Technically, the reason is the specific heat. There is some concept known as the specific heat. The specific heat of, what is specific heat? Specific heat is nothing but you could have studied in your physics lessons. Specific heat is the amount of energy which is required to raise the temperature. Okay, that specific heat is the specific heat of the land. The specific heat of the water is so much higher. Okay, so much. That is the technical definition of this. This difference of heating in land and the oceans. Okay, so now we'll see what happens is. See, this is the land surface. This is the ocean surface. The heat is coming, and I'll rub this. So the heat is coming and hitting on the land surface. It is also coming and hitting on the ocean surface. So your land is very opaque. Opaque means what? It will not allow the things to pass. But on the other hand, this is ocean, right? So it is very transparent. So your the sun's rays which are coming and touching this land surface, it will not go deep. It can't go deep because the land surface is very opaque. We know what is inside the atmosphere. Okay, we know what is it. It is so hot and so much of pressure is there. So much of materials are there, like knife, core. We know what is there inside. Okay, so it is so much of opaque. So it will not allow the sun's rays to pass. Up to some extent, up to here only your sun's rays can penetrate. Okay, after that it is being reflected back. Okay, so your land will get very heated very quickly and it will radiate back the heat very quickly. On the other hand, your ocean, see, it is very transparent. So the sun's rays, okay, when it is striking the outer layer of the ocean, your sun's rays will penetrate inside. It will slowly, gradually go inside and inside. This thing is absent here. It can't go inside. So your sun's rays will go deeper into the ocean. Okay, so it will take some time. Because your ocean is absorbing the heat, so it will take some time to absorb, and this heat will go till your ocean floor, and then only it will being reflected back. So this process will take some time. On the other hand, when on your land, it is very simple. It will hit here, it can't penetrate more, so it will be reflected back. That is why your land surface gets heated up very quickly and very fastly. This single line, like land surface gets heated more quickly than your water. This is a very important concept. Please don't forget or don't mix this concept. This concept is very important in the further lessons. Okay. So the main reason is, another reason is the specific heat that I told earlier. That is one of the reason. Okay. Also, your ocean is what to say, it is on a motion. Okay, your water will be on a motion. There will be waves, there will be currents, there will be tides there. So your water is always in the motion, but on the other hand, your land is still there. Okay, so your land is not moving and all. It is like that only. It is very permanent there. But your ocean surface, it keeps on changing. So it will be very hard for the sun's rays to stick it there and heat the water very easily. The sun's rays will very difficult for the sun's rays to get the water surface heat because the water surface is on a motion. On the other hand, your land surface is not in a motion. That is also another reason. This is an important concept that I wanted to say. So next we will see what are the heating process involved. There are 4 heating processes involved that we will see one by one. Okay. First heating process is radiation. There are four heating process. One is radiation, other is convection, conduction and advection. These are the 4 heating process. First we will see what is this radiation. Radiation is nothing but a part of insulation only. I told the sun's rays are coming, it is hitting the the outer layer of the atmosphere and it is being radiated back. Okay, so this process is known as the radiation. The land surface gets heated and cooled down because of this radiation only. It is a process. I'll read the proper definition of radiation. Radiation, it is a process by which solar energy reaches the earth and earth loses the energy to the outer space. Both are happening. Okay, through the entire process, heat travels through empty space. So for radiation to occur, there is no medium and all required. It can happen through the empty space. So the vast amount of heat energy coming to and leaving the earth is in the process of radiation only. So all objects, whether hot or cold, if you take a hot coffee or a cold coffee, both will radiate energy. Okay, that is the important concept of physics. And also one more thing is, hotter objects radiate more energy than the colder object. Okay, both hot and cold will radiate energy, but on the comparative side, your hotter object will radiate more energy. Also, one important concept to add here is, your radiation has an important relation. Your temperature is inversely proportional to your wavelength. Okay, so what is wavelength? You know, a wave is created, a crust and trough. These are the crust and these are the trough. The distance between two crusts is known as the wavelength. Okay, so regarding radiation, there is an inverse relation between the temperature and the wavelength. So if the temperature is more, hotter object, more temperature, if the temperature is more, then your wavelength will be shorter. For the colder object, your wavelength will be longer. Wavelength means the distance. This is for hot object. Then if you take for a cold object, it will be like, the wavelength will be like this. The distance will be more longer for the colder objects. That is the concept of temperature inversely proportional to your wavelength. Okay. Insolation reaches the Earth's surface in shorter waves and heat is radiated from the Earth in the longer waves. That we have studied in the previous session of the composition of atmosphere. So in insolation, make that concept very clear. Okay, the incoming short wavelength, the incoming short waves and the outgoing long waves. While this incoming short waves are coming inside, it will not heat the layers of the atmosphere, but this long waves which are being radiated back, that will heat up the layers of atmosphere. And also, while this short waves which are coming inside via insolation, there is no hindrance for these waves, but once it is being radiated back, there are so much of hindrance like carbon dioxide and greenhouse gases. These gases will obstruct these long wavelength to go out of the atmosphere. That is why global warming is happening. That it will be dealt in detail in the environment sessions. Okay, so that is about the first process, which is the radiation. Next, we are going to the second process, the conduction. So what is the conduction? I'll read the proper definition of conduction. Two objects of unequal temperature comes into contact with each other. The heat energy flows from warmer object to the cooler object, and this process is known as the conduction. To understand this conduction process very simply, you take a hot mug of coffee. Let us say the hot mug of coffee, the temperature is around 50 degrees Celsius. The hot mug of coffee is 50 degrees Celsius, and you're keeping it there. Okay, for 5 minutes or 10 minutes, you leave the coffee like that itself. Okay, you're just reading a newspaper. The hot mug of coffee is 50 degrees Celsius. So what happens? After 5 or 10 minutes, this 50 degrees Celsius will come to the room temperature of 27 degrees Celsius, and you can drink like that. So how this 50 degrees Celsius becomes 27 degree or 25 degree in the 10 minutes? You're doing any process there? You're doing nothing. Okay, that process involved is known as the conduction. So because you're keeping the hot mug of coffee, it is very hot. On the other hand, your room temperature, it is 27 degree. The hot mug of coffee is 50 degree. So these two will exchange the temperature. Okay, these two will exchange the temperature until both becomes equal. Okay, that is known as conduction. So the flow continues, the flow of the temperature continues till the temperature of both the object becomes equal. This conduction happens at a zone of contact between the atmosphere and the Earth's surface. Okay, between the atmosphere and the Earth's surface, this process of conduction happens. Okay, so that is the this process of your outer layer atmosphere and the land surface. This process of conduction will happen. This is the second process, that is conduction. The third is known as the convection. You all know, we have learned about the convection currents and all. Convection, you know, that is a cyclic process. Okay, convection is nothing but a cyclic process. I have said that example again. I'll say, take a boiler of milk and place it in the induction stove or whatever. So what happens is, if you are keeping like this, see, let us say milk is there and you are heating it. Okay, so what happens is these, okay, the part of water here, what happens is, you just, I'll say a concept. Okay, so just heating the milk, the boiler of milk, you are just heating. Okay, now you cut off the heat and you just take the milk out, and you can see that up to here the temperature will be high. Okay, up to here the temperature will be high, and the lower parts the temperature will be low. Here the temperature will be high and here the temperature will be low. What is the reason? Because of convection only. Because see, when you on your induction stove, this layer of the milk which is present at the bottom of the vessel, this will get heated fastly, and once it gets heated, it will rise and go upside. Okay, so when it goes upside, this area will be replaced by the this topmost layer. This will come down. Okay, so again this layer will be heated and it will rise above. So this cycle will be happening when you are boiling the milk or water or whatever liquid you are boiling. This convection process will happen. Okay, the same convection is only happening below your landmass, which results to a continental drift theory and all. Okay, that we have dealt already. So this is the convection. I am not going to deal more with convection because I have explained a lot more of time in our sessions about the convection. So next we will go to the fourth and last important heating process, which is known as the advection. Okay, what is the advection is? It is a process where the horizontal transport of heat by the winds, that is known as advection. Okay, so let us say that advection is nothing but your currents only. Okay, we are going to study about your hot, warm currents and cold currents in the oceanography session. But now understand that current is nothing but the horizontal movement of wind is known as the currents. So a warm current means the air mass which is having high temperature. Okay, when it blows over a surface, that surface will become heat because this warm current has moved through that. So this land surface heat will be based on that temperature which is moving above that land surface. This land surface temperature will increase. If a colder current is moving, this land surface temperature will decrease. That is known as advection. So the horizontal transport of heat by this wind is known as the advection process. So these are the four important heating process via insolation. First, we have said about radiation. Radiation is nothing but the heat is coming inside and it is radiated back. So this insulation happens because of the radiation process only. Next, we have dealt about conduction. What is conduction? Take a hot mug of coffee, your temperature automatically decreases. That is the process of conduction because the transfer of temperature takes place. What is convection? The cycle happens. That is known as convection. And the last, advection, that is known as the currents. Warm currents and cold currents. The temperature of a place will rise if it lies on the path of winds from warmer regions and will decrease if it is in the path of the colder regions. That is known as the advection, how the horizontal movement of the wind, and the heat is being decreased or increased based on the movement of which current it is, which mass of atmosphere it is, whether it is hotter or colder. That is the process involved. Now we will go on the next topic, which is the factors affecting the insolation. What are the factors? There are some 3 factors which are mainly responsible for this insolation that we will see now. So now we will deal about the factors affecting the insolation. There are some 3 important factors. The first factor is the angle of incidence. Okay. So we all know this is the earth. Okay. So sun is here, let us assume. So what happens is the sun's rays, okay, will fall directly on the earth. These are known as the vertical rays and these are the oblique rays. Okay. So this is the angle of incidence, the first factor. Okay, based on the insolation I am saying. Okay. So the vertical rays, we know it is falling very vertically. So this concentration will be on a smaller area. So there will be, if the concentration will be on a smaller area, the temperature will be at the maximum. But on the other hand, these oblique rays, it will cover a vast area. Large area it should travel. It will cover vast area. So when it is covering vast area, that heat will be dissipated. The heat which is absorbed will be easily dissipated. So temperature will be lower. So based on this movement of the sun and based on the angle of incidence, your heat or insolation, the amount of insolation received by the earth will vary. That is the first factor, angle of incidence. The second factor is the duration of day and night. We all know the duration of day and night is not equal. Only on equinoxes time, the duration of day and night will be equal. Remaining days, the duration of day and night are not at all equal. We know what is the reason for that. Okay, I'm not going to deal it again. So based on the duration of day and night, the insolation varies. If the duration of day is more, then what happens? Sun will be more in the day. So the land surface will gets heated more when the duration of day is longer. So temperature will automatically increase. If the duration of day is less, there will be only sun, it will be shining for a shorter time only. So temperature will be lower. So based on duration of day and night, okay, the temperature will increase and decrease. That is a very normal straight phenomenon. It is nothing more complex in that. If the duration of day is more, then temperature will be more. If the duration of the day is shorter, then temperature will be lesser only. That is a straight phenomenon. The third most important thing is transparency of the atmosphere. That is also an important factor which is affecting the insolation. Transparency of the atmosphere. So what happens is transparency, it depends on the cloud formation. Okay, if there is more cloud cover, then what happens? Insulation cannot penetrate. The incoming short waves cannot penetrate inside because of this large cloud formation. And if there is also more dust and all, it depends on the transparency of the atmosphere. If your atmosphere is very transparent, then insulation can happen very quickly. Okay, but if your transparency is blocked somewhere because of the formation of clouds or dust particles, then your insulation is being affected. Okay, so these are there are actually, we can add more factors, but these 3 are the important factors we can say. Okay. On the other hand, I'll ask a question. This is one of the prelims question. I think in 2017 or 16 they have asked this question in prelims. The statement goes like this: active volcanoes play a role in the insolation. Whether the statement is true or false, just try in the comment section. Just pause the video and just try it out. The statement I will again read: active volcanoes has an effect on insolation. The statement is correct only. Okay, the active volcanoes has an effect on insolation because what does active volcanoes emit? Lava. We know. Apart from lava, it also emit the smoke and dust also. So these smoke and dust will go up mix with the cloud and it will be a hindrance for the incoming short waves insolation. So your active alkalones is also a part of or has an effect on insolation. That is one thing. More or less we have finished the insolation topic actually. So insolation, I told earlier, it is a very small topic. Insolation is, you can say in a single word, the heat is coming from the sun and it is being radiated back. This process is known as the insolation. But what are the factors involved and what are the process, 4 important processes involved in insolation? That is very important. Okay. So this is the end of the session. Before wrapping up, I want to ask a simple question to you. Just write in the comment section also. The question is like, we'll take two scenarios. Afternoon 12 o'clock and afternoon 2 o'clock. Just answer in which, whether at 12 o'clock or 2 o'clock, the temperature will be maximum. Just try it out. Whether in 12 o'clock or 2 o'clock, the temperature will be maximum. Most of us will think that at 12 o'clock only the temperature will be maximum, because you all know by 12 o'clock the sun will be straight overhead. Okay, it will be very perpendicular to you. So there will be more, the area of concentration of the sun's rays will be limited to a smaller area. So there will be so much of insolation and temperature will be at the maximum. That is our assumption. That is correct only. At 12 o'clock the insolation is not that much, because at 12 o'clock the insolation is maximum because the sun's rays are falling perpendicularly on the earth, so smaller concentration, so more temperature. At 2 o'clock the sun will not be at the overhead. Okay, it will be shifting towards your north or south or east or west based on the direction. It will only, you will get the oblique rays. Okay, only you will get the oblique. If you want to test this, just go to your upstairs. By 12 o'clock you can see your sun's rays falling directly on the head. By 2 o'clock you can feel the sun's rays at the back of your head only. So that is known as the oblique rays. By 2 o'clock, since of the oblique rays, there will be lesser amount of insolation. So we will think that, okay, 12 o'clock insolation is maximum and 2 o'clock insolation is minimum. So maximum temperature at 12 o'clock. No, that's not the process. Okay, so that is not the answer for my question. The answer is 2 o'clock only. So by 2 o'clock only there will be a maximum amount of temperature, because by 12 o'clock we all know insolation is maximum. So this temperature from this sun's rays will directly hit on the land, and this land will take some time actually. This land will take some time to absorb that heat and start radiating. This radiation will start by 2 o'clock only. Okay, maybe about 12 o'clock or 2 o'clock your insolation will be minimum. That is not the case. But the radiation will start by 2 o'clock only, because it will take some time. So by 2 o'clock, you can't say by 2 o'clock there is not at all insolation. There will be some insolation there. Okay, so insolation will be coming from there by 2 o'clock, and this radiation will also come from the down. So both will be there, and heat will be maximum by 2 o'clock only. By 12 o'clock there is no radiation of heat. There is only insolation. But by 2 o'clock, since the insolation is minimum, but you will have the radiation of heat. So by 2 o'clock only the temperature is increased. Okay, I think I can extend this concept more. We'll see about the land breeze and the sea breeze also. Actually, this land breeze and sea breeze is not directly involved to insolation, but I thought we have dealt about this heating and all, heating of land and water. So this land breeze and sea breeze is just an extension of the topic. So we'll see about the land breeze and sea breeze. So what happens is, take, this is land. Okay, I'm poor at drawing but still manage. This is land. Okay, and this is water, just assume. Okay, this is land somewhere like stones, and this is land and this is water. So we all know land gets heated more quickly and it cools more quickly than the water surface. This concept we know very thoroughly, that I've done. So now what happens is, let us take the time is 10 a.m. Okay, time is 10 a.m. So this is land and this is sea. So what happens is, the temperature will be maximum here because of the insolation. Okay, because land gets heated up more quickly. So there will be more temperature here and temperature will be less here. Okay, that is okay. So now what happens is, since the temperature is maximum here, there will be low pressure. Since temperature is low here, there will be high pressure, because we all know the relation between the pressure and temperature. Since the temperature is more here, there will be low pressure and high pressure because of the less temperature. So that concept we all know, wind always blows from high pressure area to the low pressure area. So wind will blow from the high pressure area to the low pressure area. Okay, so what is this breeze termed as? What is the name of this breeze? Where it is originating from the sea. So it is known as sea breeze. Okay. Always in geography, don't confuse with the names. Okay, these names are always based on the origination. Like example, westerlies, winds coming from the west. Easterlies, where they are originating from the east. Southwest monsoon, because it is originating from the southwest direction. Northeast monsoon, from the northeast. Okay, so from where it is originating, geography, the terms are like that. Okay, so when it is sea breeze, you automatically breeze from the sea. So during day 10 a.m. the breeze will come from the sea towards the land. If you want to check this scenario, you can go to a beach by 10 o'clock or 11 o'clock in the morning and stand in a place where there is no crowd or nothing, and just close your eyes and you can feel the breeze which is coming from the sea towards the land. This is during the daytime. What happens during the night time? Night time, the positions are reversed here. Again, this is land and sea. Let us take by 11, okay, let us take by 11 p.m. okay, at night. What happens is, but by 11 p.m. there is no insolation. So automatically this your land surface heat will be lower. Okay, and your temperature in the oceans will be higher. Because why it is higher? Because your ocean is being, the heat of the sun rays are being absorbed and it went deep inside. Okay, and by night only this it will get reflected and it will take some time. So this temperature will be there only. But on the other hand, your land, the heat will be heated up more quickly and it will be cooled very quickly. Okay, it is very quick in terms of land. In your terms of water, it is somewhat slow. Okay, so temperature is maximum at the night here and temperature is low at the land surface. So now we all know temperature is low, so there is high pressure, and here it is low pressure. Wind always blow from high pressure area to the low pressure area. So the exact opposite happens at the night time. So where it is originating from? Land breeze. So it is land breeze. So sea breeze during daytime and land breeze during night time. So this is the concept involved. This land breeze and sea breeze plays a very, very important role in your prelim. Okay, they can ask about many concepts, or they can give a scenario, or whatever type they want to ask, they can ask. So don't confuse sea breeze during day. Because of this sea breeze and land breeze is happening because of the difference in heating process involved with your land and the sea. Because of this difference only, low pressure, high pressure is created and winds are blowing in the vice versa directions. This all is happening because of the insulation. Okay. Next we will see another one, breeze. Okay, let us say these are the mountains and these are the valley flows. Okay, these are mountains and these are valley flows. So what happens is, again we will take some evening 4 p.m. Okay, these are mountain floor and these are the valley floors. Okay, so now what happens is, this mountain floor will have so much of insulation from morning till 2 or 3. Insulation will be there and insulation will be at the maximum here. By 4 p.m. a thick pocket of air, take a thick pocket of air, this pocket of air, okay, it will start radiating the heat. It is land surface, so it will get heated up more quickly and it will radiate back very quickly. So by 4 p.m. and all, insulation will become minimum. So this thick pocket of air will start losing the temperature. It will start radiating back. So when it start radiating the heat back, the temperature will decrease. So when the temperature gets decreased, the air will become colder. When it is becoming colder, density will increase. Once the density is increased, the weight will become increased. So automatically this thick pocket of air will move towards the valley floor. Okay. So what to say, during the by 4 p.m. and all, this thick pocket of thick pocket of layer at the mountain floor, okay, that will start radiating heat, and the density, it will become so colder, density increases, volume or the weight increases, and it will come towards the valley floor. Okay, and it will come towards the valley floor. So by night time what happens is, this will more increase and more amount of breeze or more amount of air, the cold denser air will come from the mountain floor and will start settling here in the valley floor. Okay, that's the reason why if you go to any mountain, go to any hill station, you cannot find any house in this valley floors. People will not construct house in the valley floors, they will construct in this mountain floors only. Okay, they will not construct here. Here the area will be flat, but they won't construct there. They will construct in these mountain floors only, because they know by night time there will be more amount of cold denser coming and accumulating, and they can't withstand that temperature. That's the reason why houses or settlements are seen on the mountain floors and not on the valley floors. Okay. So now from where it is coming? Actually this breeze are coming from the mountain. These breeze are coming from the mountain towards the valley. So we will name that as mountain breeze. So this happens during night time actually. Okay, By night time only, by 4 p.m. it starts, and by night 11 p.m. and all, there will be more dense colder air dripping from the mountain floor towards the valley floor. So mountain breeze during the night time. Again in the morning, what happens? Let us see. Now it is like 8 a.m. and all, 8 a.m. to 10 a.m. What happens? Insolation will happen here. Okay, so this cold denser air, it will start to heat. There will be so much of hence fog or so much of dense air here. This layer of air which is formed at the valley floor will start heating, and the temperature will increase. Once temperature increases, density reduces and will start rising up. Okay, these breeze will start from the valley floor towards the mountain during the daytime. So since it is starting from the valley, we will name that as valley breeze. Okay, so this happens during the daytime. So valley breeze during daytime and mountain breeze during night time, and sea breeze during daytime and land breeze during the night time. Okay, because of this variation or the difference in heating of the land and the ocean or water surface, this valley breeze, mountain breeze, land breeze and sea breeze happens. Okay, this is an extension of the insolation. So with that, we are closing the insolation. So what all we have studied in insolation? Just first we have studied definition about that 51%, 35% are reflected back, no use, 14% scattered. The remaining 51% are only absorbed. How it is being absorbed? We have saw about terrestrial radiation, which is very important, and we have seen why land surface are being heated more quickly than the water surface. We have seen the reason. Next, we have talked about the 4 important processes of heating, which is very much important. They can give us a match the following. They can give in prelims and all. So please take care of that section. And we have seen about the factors which are responsible for insolation, like the axis or the angle of incidence, and the duration of day and night, and the transparency of the atmosphere. These are the factors involved in insolation. And we have seen about the small topics like by 12 o'clock or 2 p.m. which scenario the temperature will be maximum. And we have dealt in detail about your land breeze, sea breeze, mountain breeze and valley breeze. With that, I will close this insolation, and we are coming to the end of the module 2. We have seen about the components of the atmosphere, and I have talked about the insolation also. So module 2 is done. Next we will go to the module 3, where we will see about the temperature. There are many zones, temperature zones and pressure belts and all that we will deal in the module 3. So thank you for watching this video. Please subscribe and like this video. Thank you.